to do that. Okay, chapter 10. Chapter 10 is called rotational motion. Rotational motion. So we have the introduction about the vanes. In which cases we like to say what is most important invention in the earth is this one. It's called wheel. This is the most important. And regardless of what you say, is this invention is better than Einstein's relativity. This is much more practical. Look at all the machine, all the moving things is involving the wheel. So we have to understand what's going on in here. The first of all, this called from here rotate. There's a clockwise rotation. There's what we call counterclockwise rotation. This is clockwise rotation from the here to here, in which case it's a theta. So from here to here, we call angular displacement. Angular displacement. That angular displacement is basically delta theta. Delta theta is an angle, or you can just say theta. First, we like to say that this theta have a lot of different units. The first unit is called revolution. The second unit is called degrees. And the third unit, radians, is the most useful unit in the circular motion. Okay, one revolution is equal to 360 degrees. That is equal to 2 pi radians. So from this, you know how to make the conversion, okay? So in that case, 180 degrees is equal to pi radians. So we like to say why we do that, okay? So things come up very obvious. If we express the theta angle in radian, we're going to have a lots of advantages. In which cases, suppose that we express this in radian. And there's a dimension there, is motion. In these cases, then L can be very, very easily to express in a very linear function. In which cases L is, in which cases I arc for sure. L, or sometimes they using S. In your book is S. The arc length is S. So that is equal to the in radian. Or theta in radian is equal to S divided by R. When they divide each other, in their cases, they have no unit. We can name this new unit is called radian unit. So in these cases, we have a theta radian. This is called angular displacement. So now we like to say what we're talking about in linear velocity. So we like to say this. This is, we like to talk about in here, linear motion. And in here, we like to say rotational motion. In the linear motion, we like to say one thing, in which cases is displacement. So L is displacement or position changes distance. Okay, and in here we call angular displacement. So now the next thing is we have a velocity. All right, we have velocity. What is a velocity? Velocity is, which case is v is equal to time rate change, time rate. Suppose that use x, right? Time rate change or position. Or L. So V is like that. So now, what is angular velocity? Is omega. The angular velocity is equal to time rate change or angular displacement. So delta theta delta t. Okay, so now we have association, velocity or association, in which cases is ACERA delta t. And then in here, what is the time rate change of equal to angular acceleration? That is equal to time rate change or angular velocity. See, all this is related with linear motion, all this is related rotational motion. So they are nicely correspond. So now we like to say, how about motion equation? So in here, we go through the motion equation. 8.1 and 8.2, the motion equation, rotation, motion equation. Rotation, motion equation.
You need 10? Or chapter 10?
10. There you go. 10.1, 10.2. Okay, so we like to draw the analogy so that you will know. So for the linear motion, so linear, we have a four equations. The linear velocity is v sub f equal to v sub I plus at. And x sub f equal to x sub I plus v sub I times t plus 1.5 at squared. And then x sub f equal to x sub I plus 1.5 v sub I plus v sub f times t. And v sub f squared equal to v sub I squared plus 2a x sub f minus x sub I. Ladies and gentlemen, so each one is corresponding. V is corresponding in the rotational motion, is rotational motion is equal to omega. So basically, V change to omega and A change to alpha. Motion equation. So if you do that, this is equal to omega sub f equal to omega sub I plus alpha t. And that phase of, and then x will change to theta. So theta sub f equal to theta sub I plus omega sub I times t plus 1.5 alpha t squared. And theta sub f equal to theta sub I plus 1.5 omega sub I plus omega sub f times t. And then and then omega sub f squared equal to omega sub I squared plus 2 alpha theta sub f minus theta sub I. So can you see the relationship? Such nicely done. And from linear motion to rotation. So, ladies and gentlemen, we want to do the lab today. So